Good day. I'll be showing you how to use the remote PC that we will be using in this particular laboratory. First, we go to Start and access AnyDesk. Make sure that AnyDesk application is installed on your PC. Once it is open, type the remote ID that you will be using. It is located on your Canvas laboratory activity and you will be entering it on this particular bar. Click on Connect. From there you will see your equipment. At the same time, the particular application that we will be using is Siemens TIA Portal. Now, as we try to open the application, we will now be creating a new project. Type your project name, timers, then click on Create. Now let us configure a device. From there, we will be adding a new device. Select Simatic S7 1200. Select the CPU, then unspecified CPU. Then, click on Add. It says here that we need to detect our PLC since the device is not specified. So we will be clicking on Detect. From the detection dialog box, we will be selecting the type of PGPC interface. For this one, we will be using PN, which stands for protocol, or Profinet I mean. And for the PGPC interface, we will be using Intel Ethernet connection. Once this one is configured, we start to click on Search. Notice that we have found an accessible device PLC, which is located at this particular IP address. Once the scan is completed, select on the PLC device, then click on Detect. Assign an IP address, click on Yes. So the additional IP address was added. This means that we are now connected to the PLC. As you would notice, it already detects our PLC in the particular laboratory and is a schedule slot. Before we proceed on the programming, let us try to first configure the expansion module, since the expansion module has a default input-output address. Now, in setting for the input-output address, we will be going to click on the device and select on Properties. From the Properties, we will be clicking on I/O addresses. We will be changing the I/O addresses since based on our manual, our I/O address must start at 2.0. Same goes with the output address. We must change it from 8 to 2.0. Once that it is being set, we will now be right-clicking on our PLC, then download to device, and we will be downloading the hardware changes, which is now, we call it as hardware configuration. So click on Load. Then click on Start On. Once the configures are all set, we will now be trying to program our PLC. So from the program blocks, we will be adding a new block. From a new block, we will be clicking on the function block FC and selecting our language as LED, which stands for ladder logic. Click on OK. Now we will be proceeding to ladder programming. In this particular session, we will be using timer programs or timers to blink a particular pilot lamp in our mechatronics training. Okay, let us start with building the ladder program. In order for us to have a blinking light, let us first have a timer circuit or a timer instruction in a particular ladder diagram. So we will be dragging one empty box. Let the small green square turn into green and add a particular address. So for here, I'll be using TON, which means as timer on. So we will be naming our timer as timer 0 dB 0. Then click on OK. From there, we will be having a preset time. For the blinking, I'll be using 1 second. To type 1 second on the preset time, we will be pressing 1, then S. Stands for 1 second. The next one we will be having is a normally closed contact at the left side of the ladder, and on the right side of the ladder we will be putting a coil. We will be putting some addresses later on. Next, we will be putting a wrong branch or line down in the particular ladder diagram. Then we will be putting a normally open contact and again an empty box, which stands for another timer. We need 2 timers for blinking of the lamp. For this one, we will be again using TON, stands for the timer on delay. The next, we will be naming this one as IEC timer 0 dB1. Then click on OK. Next, we will be adding now the particular address for each and every contacts and coil. For the normally closed contacts, I'll be putting this one as a virtual bit, which stands for M0.0. Next, our output coil, which is our lamp, is at address Q2.0. Lastly, for this normally open contact, we will be putting IEC timer dB0. Then we will be putting it as an executable, so we will be using Q. We are missing one particular instruction or particular contact, and this is a normally closed contact in between the wrong branch and the timer. In this normally closed contact, I'll be putting this one IEC timer dB1. Then the execution will be Q, stands for output. Once it is all set, I'll be going now to the main program and put a empty box in one network or in network 1. I'll be putting an address here such as block 1. It means that in that particular main program, the block 1 function will be executed. And in the block 1, as you can see, is our ladder program where the blinking of the LED lights will push through. Now we need to download the program. To go to download the program, we need to click on this icon, download to device. So click on load. So once the loading is completed, we may view here on the simulation if the program is blinking. As you can see, the Q2.0 is blinking. Now let us see in our camera, in our actual scenario, if our LED or if our lamp, green lamp, is blinking. As you can see, in our PLC, in our mechatronics trainer, the LED light is blinking. So that is how we try to program and download the program to our PLC. That's all for now. Thank you.